Hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been creating a series of video presentations that are based off of the Mozilla Developer Network Learn Web Development series. I'm in the JavaScript portion of that series, and we're going over some JavaScript building blocks, and we're talking functions. And we're switching from standard functions into what are called anonymous functions. An anonymous function is a function without a name. So when you look at this, this is not an anonymous function. So far we've created functions like this. Now ours were things like add to or whatever, okay? But this function right here, it's called my function. So when you invoke it, you use the name my function. And it has no parameters. So when you invoke it, you don't pass it any parameters. Now, we could have also written it like this. What's the difference? Well, it's pretty obvious. This one doesn't have a name. Since it doesn't have a name, it is what's known as an anonymous function. So notice, it won't do anything on its own. You generally use an anonymous function along with what's referred to as an event handler. We've looked at event handlers a little bit thus far, and we're going to talk about them much more in depth and breadth of coverage in a later lesson. All right? So as it says, you generally use an anonymous function along with an event handler. For example, the following would run code whenever the button is clicked. So what this is saying here is when my button, which is this, when my button is clicked, in other words, when the onClick event runs, we want that function to run. So in other words, whenever we click the button, an alert should come out and show on the screen with the word hello in it. You can also assign an anonymous function to be the value of a variable. Now that's kind of neat. JavaScript is fairly unique in that, in that you can use functions like variables. All right, and that's what they're doing here. It says this form of creating a function is also known as a function expression. All right, and don't worry about the hoisting part right now. They're just saying that there can be some confusion depending upon where that particular thing is located, okay? So to invoke this now, you'd say my greeting. That would invoke that function. As it says, this effectively gives the function a name. You can also assign the function to be the value of something else. So this would call it, and it would assign it to another greeting. And they go through that whole rigmarole in there, and then they say, but that'd be confusing, so don't do it. All right. When you're creating functions, it's better to stick to this form. Yeah, when you're first starting. As you're starting to work with more and more anonymous functions, and you start to work with event handlers, you're almost always going to do it like that. All right. In all of these examples that they've been showing in here, that's just open and close parens, open and close parens, open and close parens. All right, open and close parens, etc. What goes into those parentheses are referred to as the parameters of the function. And I've given this example before. Maybe that's not a good example, but maybe it'll at least pass and it'll make a little sense to you. And that is that let's suppose that I come home from work, and this isn't the case anymore just because of the fact that I don't have any kids living at home anymore. But let's just say that it was back in the day when I did have kids living at home, and I come home and I go and I look in my daughter's room and it's a pig pen. Now we're assuming here that my daughter, when I talk to her, she's kind of a smart aleck. So she comes home and I say, Mackenzie, clean the room. And she looks at me and said, gee, Dad, what room? So if I said clean the room, your room would be a function parameter. It's extra information with a function parameter that the function needs in order to be able to perform its task. Parameters are also known as arguments. They're also known as attributes. It just depends on the book you read. All right. Some functions you definitely do not put in. You never provide parameters. Other ones you virtually always do. Sometimes you need more parameters. So like with replace, this says I want to replace every occurrence of this with this. So it needs both parameters. When you've got multiple parameters like this, they're comma separated. Sometimes parameters are optional. All right, we'll get into that in even more depth and breadth of coverage a little bit later on. Okay. Now they talk about function scope here, and I should be able to come back here and actually show you a couple of examples of this. Now, str was defined inside of main. So str begins life here and it ends life here. All right. N1 is defined inside of main, so it begins life, etc. Same with N2, same with choice. Now, I want N1 and I want N2 to be available to these functions. So I have to do what's called pass those values into the function. So not only right there on what you see in gray, not only am I attempting to invoke or call the add2 function, but I'm passing N1 and N2 in as parameters. So it's the information that add2 needs to do its job. What's its job? Returns N1 plus N2. Well, if I didn't pass that in, it would have nothing to add. All right. So what I want you to understand here is, and I'm not doing a great job of it, but I want to explain it to you anyway. Let's say outside of here, I come in here and I decide I'm going to define N1 and N2 here. So let N1 and let N2. So I'm defining them outside of everything. Now I can come in here and say N1 equals this and N2 equals this. Well, what did that buy me? A whole heck of a lot. Because now when I call these routines, since I defined N1 and N2 outside of any function, they're now global to the program, which means I don't have to pass them in. And I don't need them in here either. The system just knows they're global, meaning they're known program-wide. Now, that said, it's a good thing and that it results in a little easier code, but you should always strive to not make your variables global. When you make your variables global, you open up your program to what are called side effects. Sometimes side effects are what you want. Sometimes they're not. Look at it this way. Again, I'm giving you a non-computer example that I've used with students before. All right. If I go out and I go out to inside Rankin, there's things that I can do out here that you can't do. All right, once I log in, because as an instructor, there's things that I can look at. All right, so I can go out to academics and I can find out grades and a few other things. I can look at past courses that I've taught. All right, there'll probably not be any future courses yet, but once that gets filled in, I can go out to there, etc. And there's even some, if I go out to faculty, there's even some information in here. If I go out to, let's see, my pages, there's some stuff in here that's personal to me. Now, there's some way that I can go in here. I don't even know what it is, but I can go in and I can make changes. So let's say that I moved. All right, let's say that I sold my house, bought a new house, and I moved someplace. I can come into Inside Rankin and change my address. Not only can I change my address, people in payroll, so if I forget to do it and I call them, they can change my address. But I can't go in, for example, and change Mr. Corrigan's address, nor can he change mine. All right. So who cares? Why am I telling you that? Well, imagine that I could go in and I could see what I make. All right. So I could see what I make per year. So I could look at my salary. That would be pretty viable. It would make sense. But now let's suppose that through some quirk in the system, when I go in there now, it asks me if I want to see everybody else's salary at Rankin. Now, ooh, that'd be interesting. So I look at it. Well, that would be unintentional side effects because it would be allowing me to do something I shouldn't really be allowed to do. So sometimes when you have a side effect, it's a good thing. Sometimes it's a bad thing. Typically in programming ease, when you've got a side effect, the reason that you get one is you create a global variable. And when you create a global variable, that means that any routine in the program can change the value of that variable, and it's a permanent change until or unless it gets changed again someplace else in the program. So it's not a recommended thing to do. So that's scope. So when you define stuff outside of any function, it's got global scope. On the other hand, if you define something inside of a function, it's got local scope. So str is defined here, so it's only known within main. All right. N1 is defined globally, so I can use it in both places. All right. If I had come in here, I didn't do this, but had I come in here and said, I don't know why I do this, but let's just say we did for some reason. Let age equal 12. Age is known in here and no place else. It's not known in here, or in here, or in here, or in here, etc. It's what's called local variable with local scope, meaning it's from where it's defined till the end of that routine. That's pretty much what we had with the str that was up above here. All right. I mean, again, they do some stuff with scope, and they got this example with a zoo in here. It's not that there's anything wrong with it. I'm just trying to give you more realistic type of examples. All right. And let's see, we're at 12. Oh, good. We can finish this section. Notice it says you can call a function from anywhere, even inside of another function. So one function can call another function. This is oftentimes used as a way to keep your code, they call it tidy, but just make it more manageable. So as they mention here, if you've got a big complex function, it's easier to understand if you break it down into subfunctions. Let's go back and take a look at what we had here before. This was choice, so this is the choice, right? Remember that? We asked them to enter something? Okay, and they needed to know the string. So I'm going to say here, let choice equal, and I'm going to grab all of this code that you see right there, that code. All right, I'm going to grab every bit of that, and I'm going to say let choice equal, and I'm going to call a function called make choice, and I'm going to pass into that str because it'll need that information. All right, and now I'm going to come in here and I'm going to write a new function that's called make choice, and I'm going to pass in that str, and I'm going to put this back in here. Now don't worry, I'm going to have to make a couple changes, but that's okay. All right. So I've got here var, not var, let's just call it C for choice. Let C equal, and we're going to give all that information. So we're going to validate that C was equal to 1, or C was equal to 2, or C was equal to 3, or C was equal to 4, or C was equal to 5. If not, we're going to ask you to do it again. So once we fall out of here, and this should have been a while and not an if, because this will force you to stay in there until you put in something that is valid. All right, so I'm going to type in here now, return C. What is that doing? Well, now main has got one less thing that it's doing. See that? Main now has taken the responsibility of making a choice and has pushed it off into its own function. All right. What if I grabbed all of this and I said this? I'm going to call here call correct function. Kind of a silly name, but you get the idea, hopefully. And I'm going to come down here and I'm going to say function, call correct function. I may need to pass something into that, but that's okay. We'll fix this in a minute. I'm going to paste this in. Okay. Now, it's got switch on choice. Well, then it needs choice. So I need to pass choice into this, which means I'll need choice here. Again, let's just call it C. Here C means choice, and here it meant choice, which is fine. I don't want that. I'm sorry. What did I do here? We had make choice. We wanted to put call correct function here. Well, I goofed this. Yeah, this was correct. I'm sorry. So this should say choice. We'll make that C. And we'll switch on C. All right. Guess what? The program still works. But now again, notice what we're doing. We're taking main and we're shrinking it down. And we're doing some of the work. We're offloading the functions. If you look here, here's a good reason for creating a function. This code, really the code that's in here, that code is actually doing, the same thing, except in one case it's validating N1, and in the other case it's validating N2. We could put that into a routine. All right. Plus, we can take this str, we can remove that from here now, and that's what we want to do in here. So we don't have to pass it in anymore. We just actually create that right there. So notice how much smaller main has gotten. And again, if we broke this up again, we'd have just a couple lines of code here and here and here. That's what you should shoot for. Your main part of the program, where the program begins, should be what's called a driver. And a driver, a good driver, is like a good supervisor, meaning that rather than it doing all the work, it knows how to delegate authority so that the right people get called for the right work. All right. And that's pretty much it on this one. So we have now done make decisions, looping, and functions. I think that was just the functions one, wasn't it? Yes. So next, we're going to go into build your own function. So we've got 1, 2, 3 more to go. Remember, I'm not going to be doing these exercises that are in there. So I'll come back to build your own function in just a couple minutes.